This video is about composite materials. Composite materials are made by mixing two or more different materials together. Now, the advantage of doing this is that you get the properties of one material enhancing the other. Now, one example of this would be reinforced concrete, whereby the concrete provides a great deal of compressive strength, whereas the steel bar inside provides good tensional strength. So you get the properties of both materials there combined together. The difference between composite materials and something like alloys, where you've also got a mixture of materials, generally can be seen by the fact that if, in a rudimentary sense, you cut through the material to see its cross-sectional structure, you can generally detect different elements of different materials, whereas in an alloy, they are inextricably linked together and you can't differentiate between one metal and the other. Now, there's many different types of composite materials because obviously we combine lots of materials together in various different ways. And you could argue that even painting a piece of wood turns it into a composite material by applying the different characteristics of the two materials there. Composite materials can be broadly broken down into three main groups. Firstly, you have fibre-reinforced composites. Now, a fibre is effectively a strand, like a woven strand, a woven material, and this is normally combined with resins or matrices effectively to hold those strands together. An example of this being something like glass-reinforced polymer or carbon-reinforced polymer. In addition to this, you have particle-based composites. Now, particle-based composites effectively consist of particles or tiny amounts of many different materials that are joined together, or two or more materials joined together. And finally, you have sheet-based composites. And sheet-based composites, as you would likely guess, are in sheet form. One area of composite materials that kind of straddles these categories, I would say, are timber-based composites. Timber-based composites are obviously made from woods, natural materials, combined with resins or glues effectively to hold those particles, those fibres, or in fact even sheets or veneers in some cases together. You could argue that these, as I say, straddle the various different categories. So MDF, you could say, is made of fibres, or if it's sanded down very small, you could say there's particles there, and it obviously comes in sheet form. So it fits into various different boxes, and that's where this can become a little confusing. Okay. The other thing that you need to be aware of is the fact that timber-based composites, in the sense of the exam, might also be discussed as man-made boards or manufactured. So, in a nutshell, we have fibre-reinforced composites, particle-based composites, sheet-based composites, and obviously timber-based, man-made boards, manufactured boards, which kind of fit into various different categories depending on which we're talking about. In terms of timber-based composites, there are a range of different types of boards or sheets effectively that are made from timbers. Examples, this being things like plywood, blockboard, sterling board or oriented strand board as it's sometimes called, and so on and so forth. Now, general benefits of using timber-based composites are the fact that obviously, unlike natural materials which have lots of moisture in them, have a tendency to perhaps warp or twist or bend. Because these are formed often, in the case of things like MDF, from particles or from tiny fibres that are pressed together, they're a lot more stable as materials, and in that sense they also have equal strength and toughness and things. They're almost a lot more of an engineered material than what a natural material is, so it's very likely that all along the board it will have very similar characteristics, whereas if we cut down a tree there could be weaknesses such as where branches attach to create knots in the wood and so on and so forth. Other advantages of timber-based composites are the simple fact that they often come in sheet form. Now, if I'm a manufacturer, I often, for example, if I'm producing perhaps flooring or furniture, I want to have a board that will come in a particular thickness, and I want that thickness to be consistent across, and I also want my sheets quite often to be very flat, and timber-based composites solve this problem. They do this very well. Now, some examples of fibre-based composites are glass fibre reinforced polymer, or GFRP, and carbon fibre reinforced polymer, CFRP. And it's important to have these words remembered if it comes up in the exam question. Now, quite often we abbreviate these things to glass fibre or carbon fibre, but sometimes it's good to be particularly specific about the wording of these because the exam can be quite critical in this sense. Glass fibre and carbon fibre reinforced plastics are obviously made with a mat or a series of fibers that are kind of woven together. Now, these are then combined with a liquid resin or liquid polymer that creates the matrix that surrounds those fibers and basically holds them in position. Now, the advantages of these sorts of materials are the fact that we can mold them very well around various different shapes, and the polymer will hold them in place. As with polymers, which have very good strength to weight ratio generally, but are not the strongest of materials, the advantages of things like glass fibre reinforced plastic and carbon fibre reinforced plastic is that the fibres give lots more strength to the actual matrix or the polymer as such. This can also be noticed in things like reinforced concrete. The concrete is effectively the matrix. Now, concrete obviously is a particle-based composite in itself, but if we insert a fibre into that, in the case of this, a steel rod, I know it's hard to think of a steel rod being a fibre, but it effectively is. It's just a very large fibre or strand of steel, effectively. This provides a great deal of tensional strength to add to the existing compressional strength of the concrete. Another example of a modern material fibre that is used in composite materials is Kevlar fibres. Now, this is a mixture of aromatic and aramid nylon-like molecules which are spun into fibres, and this is often used on things like bulletproof jackets, where we have very high strength to weight ratio, but also that toughness, that resistance to cutting, and that resistance to sort of flames, and resistance to many other things like this as well. Now, the third key area of composite materials is particle-based composites. Now, particles, as you would imagine, are very small materials or parts of materials that are kind of bonded together. Now, the advantages of particle-based composites, or their properties effectively, is that they have very high strength under compression, as I discussed with concretes, though not so much in tension, hence why in concrete it's often important to reinforce the concrete. They've got a uniform structure, as we talked about with things like MDF, and they're normally free of surface defects. Another key example of particle-based composites which you should know about are cermets. These are a group of composites where they are a mixture of generally metal and ceramic particles. Now, one example of this is tungsten carbide, where you're combining the ceramic tungsten carbide and the metal cobalt together. And it's used extensively for things like cutting tools. You might find your knives at home actually have a ceramic tungsten carbide edge, and often things like drill bits where they have to be particularly tough and shock resistant but also resistant to high temperatures will be in those cases. The use of tungsten carbide, for example, in knives has replaced other materials quite recently, like stainless steel, for example, where these materials are so hard and tough they require sharpening very, very little. Now, as I said before, in terms of sheet-based composites, you could argue that most timbers fall into this category quite easily, but also timbers that are laminated are also considered sheet-based composites. And quite recently, another modern material that you should be aware of is the alu composite or aluminium composite, whereby two sheets of aluminium effectively sandwich a core of polyethylene. Now, this is quite useful because it has the thermal and insulation characteristics of the polymer inside the foam layer effectively, and it also has good strength, and you can machine and cut and drill and bend this much like you would other sheet materials.